Let's learn about a cone today. We normally have two types of cones. One is the right cone and another one is an oblique cone. The right cone is the one which has got a perfect left and right sides of the base circle to be equal. An oblique cone is a cone which has been tilted a little bit to one side. Just something like which I'm tracing here. So a cone which is tilted to one side is an oblique cone. Today we are talking about the right cone. The right cone is having two parts basically. One is the base circle, this part. This part down here is the base circle, and the other one is the lateral side. These are the two parts. The base circle is having base radius, which is here. This is a base radius here. And we have a central height, which is another name for it, is an altitude or a height. This one, the one is the center. The one here on the slant is a slant height. When we get a chance to cut through the slant height as well as through the base circle here, we are going to get a shape which is exactly looks like this. The slant height goes to be a radius of a bigger circle, and the total area of the slant height is going to be a section of the larger circle. Which part of it is? We will find out that. The base comes to be a smaller circle with its own base radius. This is the one here. Good. Now, what is the relation between this part of the large circle, which is part of a circumference, and this part of the small circle, which is also the complete circumference? Circumference of a circle, C, is equal to pi d or 2 pi r. The small r is in here. The circumference of the big circle, in which it is only part of it shown here, but if it exists, it is equal to 2 pi. Again, the radius is going to be s. This is complete circle. Okay. Now, which part of is this section of the circle? When we think about the area, we need to know what part of it is from the bigger circle, which is this part divided by the total part is the ratio of the area which we see, which is going to be 2 pi small r, which is this part, divided by 2 pi slant height, or this is the larger radius here. This is the ratio of the area which we see from this section here. Here 2 pi cancels out 2 pi. Then it's going to be small r divided by s. Part of the circle is here. Now, the area of the small circle, this one, is normally area of small circle is equal to pi r square. That's just a formula for it, pi r square. Area of large circle, or section of the circle actually, is equal to pi slant height square, which is a total of it, of small r into s ratio, that part of the big circle. This square cancels out the small r here. Is going to be pi slant height, and the radius, small radius. This is area of the section of the large circle, which is the side of the cone. So the total area is going to be, area of the total is going to be area of the cone, which is area of the small part, small circle, which is the base, plus area of the side, the larger circle section, which is equal to pi r square plus pi rs. That's it. Let's give it an example on this one. When we are given the small r, let me change the color for a better view this time. When we have this small r to be 4 centimeter, and when we have the altitude or the height to be 8 centimeter, we can use the Pythagoras theorem to find out the dimension of the slant height, which is square root of 8 square plus 4 square, which is 64 plus 16, which is square root of 80, which is centimeter. Now, once we have these parameters, we can find the total area as, we can use this formula here. Total area is equal to pi small r square, which is 4 square, 16, plus pi is a common in here, small r into slant height, which is equal to pi 16 plus 80 is equal to 4 root 2, 4 times 4, no, 4 root 5 in fact here, 4 root 5, which is equal to, because 16 times 5 is 80, so 16 comes out to be 4, then 5 remains in the square root, right? Okay, pi 16 plus 16 root 5, which is equal to 16 pi 1 plus root 5. This is just as an example to calculate it. This is how we calculate the total surface area of a right cone. Thank you for watching.